In this video, we are going to solve few problems from propositional logic. We have been given the problem P implies Q and P implies R equivalent to P implies Q and R. We have to prove this logical equivalence. There are two methods to do this. One is using a truth table and the other method is algebraic method. In this equivalence, there are three variables. So the number of rows in the truth table is 2 raised to 3 equals 8. First, we will prove the equivalence using truth table. The columns are P, Q, R, P implies Q, P implies R, P implies Q and P implies R. Next is Q and R, and finally P implies Q and R. Now we start entering truth values for each column, starting with P. The first 4 rows are true and the last 4 entries are false. For column Q, first 2 entries are true and then 2 false, and so on. Enter all values. The truth values for column R alternates between true and false, starting with true at the top. The next column is P implies Q, which depends on the truth values of column P and Q. Whenever P is false or Q is true, the P implies Q column is true, otherwise false. Enter truth values for P implies Q column. Similarly, you can evaluate the P implies R column using P and R column values. Enter values for P implies R column. The column P implies Q and P implies R uses AND logic, which means both P implies Q column and P implies R column must be true for this column to be true. All other entries are false. Now enter truth values for P implies Q and P implies R column. The column Q and R use AND logic. Therefore, if Q column and R column values are true, then Q and R column is true, otherwise it is false. Now enter truth values for the column Q and R. Final column is P implies Q and R can be evaluated from Q and R column values and P column values. Enter truth values for P implies Q and R. If you compare the truth values of column P implies Q and R and P implies Q and P implies R column, then you find that they are same, hence the equivalence is valid. Now we give algebraic proof for the equivalence. In algebraic proof, we simplify the logical equivalence so that the left-hand side compound proposition is equal to the right-hand side compound proposition. We can perform the simplification using logical identities you learned earlier. If you are not familiar with the identities, then I suggest you watch my videos on logical equivalences. A list of logical equivalence is given in the description. To prove the logical equivalence, we need to simplify the implications on both sides of the equivalence. We will use this identity to simplify it. P implies Q is equivalent to not P or Q. Now the new equivalence is not P or Q, and not P or Q is equivalent to not P or Q and R. If you observe, the left hand side preposition is similar to distributive identity. If you don't know about distributive identity, you can click on the link above for the logical equivalence of distributive identity. The distributive law states that P or Q and R is equivalent to P or Q and P or R. Replace left-hand compound preposition with P or Q and R by distribution laws. Now our equivalence is not P or Q and R is equivalent to not P or Q and R. Since both sides of the logical equivalence is identical, it is valid and hence proved. One advantage of algebraic method is that you can avoid making bigger truth tables. However, you must know all the logical identities to use this method of proof.